A rare event is unfolding in the solar system. The interstellar comet 3I Atlas, a visitor from beyond our sun's reach, is now passing near Mars, offering an unprecedented chance to observe it up close. For the first time, orbiters around another planet are turning their instruments toward an object that originated outside the solar system. NASA's Mars Reconnaissance Orbiter, ESA's Mars Express, and ExoMars Trace Gas Orbiter, and China's Tianwen-1 have all shifted their focus to track this faint traveler as it sweeps within 30 million kilometers of Mars. In this video, we'll explore the discovery, the science, and what comes next for this interstellar visitor. Let's get started. 3I Atlas was first detected on July 1, 2025 by the ALAS Survey Telescope in Chile. At first, it appeared unremarkable, a faint, slow-moving speck, until its orbit revealed a crucial detail. It wasn't gravitationally bound to the sun. That meant it was interstellar, traveling through our solar system on a one-time trajectory. This makes 3I Atlas only the third confirmed interstellar object after Oumuamua in 2017 and Borisov in 2019. Unlike those earlier visitors, however, 3I Atlas was discovered early enough to organize an extensive observation campaign. Its path brought it unusually close to Mars, making it possible for orbiters there to take part. On October 3, 2025, the comet passed just 30 million kilometers from the red planet, close enough for sensitive cameras and spectrometers to detect its gas and dust emissions. NASA's Mars Reconnaissance Orbiter, MRO, is using its high-rise camera, a half-meter telescope capable of observing fine detail on Mars, to capture faint images of the comet's coma and tail. Though the nucleus is too distant to resolve directly, high-rise may detect brightness variations and tail ripples caused by interactions with the solar magnetic field. The European Space Agency, ESA, redirected its Mars Express and ExoMars Trace Gas Orbiter, TGO, toward the event. Their instruments, including the high-resolution stereo camera and CASIS, can analyze the spectra of sunlight reflected and absorbed by the comet's gases. Colin Wilson, ESA's project scientist, explained that while full detail isn't expected, these measurements could still reveal the chemical makeup of the coma and its overall activity pattern. China's Tianwen-1 orbiter joined the observation effort, adding another viewpoint from a different orbital angle. For several days, Mars became a temporary interplanetary observatory with all active orbiters united in studying an object that formed around another star before it vanishes again into deep space. Every interstellar object offers a direct sample of another planetary system, matter shaped in a completely different environment, likely billions of years ago. 3I Atlas gives scientists a rare chance to compare alien chemistry with that of local comets. Observations from the James Webb Space Telescope, JWST, have already revealed a striking difference. Unlike most comets in our solar system, where water vapor dominates, 3I Atlas emits primarily carbon dioxide, with an estimated CO2 to water ratio of 8.1. This suggests it formed in a much colder region of its home system, one where CO2 ice is abundant and stable, perhaps similar to the outer Kuiper belt, but around a dimmer or younger star. The comet's dust also behaves differently. Polarimetric observations indicate an unusually strong negative polarization, meaning the dust particles scatter light in a way rarely seen among solar system comets. This could imply compact, radiation-hardened grains that have traveled for millions of years through interstellar space. 3I Atlas's environment near Mars is adding another dimension to the story. It appears to be moving through a disturbed region of the sun's magnetic field, where charged particles twist and interact with the comet's ion tail. If Mars orbiters detect waves or distortions in the tail, it would be the first direct observation of solar magnetic influence on interstellar material. Together, these findings are building a more detailed picture of how planetary systems expel icy bodies and how those bodies evolve as they drift between stars. Compared with Oumuamua, which behaved unpredictably and showed no visible tail, or Borisov, which resembled a typical comet, 3I Atlas sits between both cases, active before it escapes again. Several concepts, including NASA's proposed Comet Interceptor and ESA's similar studies, are being refined using lessons learned from this event. Still, scientists remain realistic about the limits. The comet is faint, fast-moving, and difficult to image sharply. Many results will rely on indirect measurements, changes in brightness, gas spectra, or tail orientation rather than resolved imagery. Even so, these fragments of data will help refine models of interstellar chemistry and the evolution of small bodies moving between stars. 3I Atlas's brief visit reminds researchers that cosmic discoveries often come without warning, and that adapting quickly may be the key to studying them before they're gone forever. 3I Atlas's flyby marks the first time an interstellar comet is studied from another planet. For a brief moment, Mars became our window to another star system. Its passing reminds us that even across galaxies, we are connected. Enjoy.